So in this last set of problems, we're focusing on average rate of change. This is easy. You've been doing this probably since 8th grade. When you hear average rate of change, I want you to think slope. So some of you probably can figure out what we're about to do here given just that. Our formula for slope is change in y over change in x, right? And the way I'm going to write it here for this particular example, so notice we're given a certain interval from -4 to -3. So I'm going to write f of -4 minus f of -3 over -4 minus -3. So really this is the same slope formula that you've always used, y2 minus y1 over x2 minus x1. I'm just writing it in a little bit more of a grown-up way. And then we know on the bottom -4 minus -3 would be a -1. On top, well, we need the graph to figure out what's happening on top. So -4 is here, -3 is here. F of -4 is 20 is the y value there, minus 60 is the y value at -3. 20 minus 60 is -40 over -1 equals 40. So that's my average rate of change between -4 and 3. And notice it asks you also to plot a line segment to represent this. So what that should be is just a line connecting those 2 points. Okay? And the relationship here, this is called, by the way, this is called a secant line. And what it represents is the average rate of change between 2 points. And notice my secant lines would have different slopes depending on where I drew them. But this particular one, well, if I do rise over 1, I go over 1 up 40, which is exactly what we found in my calculations. So again, average rate of change is exactly the same as the slope problems you've been doing since 8th grade.